In this video I revisit AP series and GP series coding. The earlier video I had made, you would have realized that it's not very effective. At best you can use only AP series, and that too you might get about half of it. That's the best it can do. But this one is a different way of looking at it, and it should be a lot more effective than that. Now our objective is again to try and losslessly code a value m within a value s, where m is of the order of 2 power l dash and s is somewhere around 2 power l, where l dash is much larger than m. Right now I shall only consider a specific example, and we will not, where we assume L to be equal to 64. That is a 64-bit number, which is not uncommon. 64 bits. Here I shall. Now the thinking behind this is simple. Actually, we need not brush. You can brush up the AP series and GP series. We know the first term is A, common difference is D. The AP progression is A plus D, comma, A plus 2D, and so on up to A plus n minus 1 into D. Likewise, GP series, the first term is A and common ratio is R. The sequence is A, AR, AR square, comma, AR power n minus 1 up to n terms. Now here what I do is, since I'm taking L is equal to 64, I don't know L dashes yet. The objective is simple. For instance, what we think of initially is, what if we have different, simple AP series itself, what if we have different common differences and a fixed number of terms for those different common differences. Then again we assume another common difference based on the previous one, and a fixed number of terms for the next common difference. And like that, so we'll have, we can start off like this. The way I went off is, first I assume set aside 1 bit, okay? Or let's say I set aside 1 bit and 7 bits. So 1 bit to distinguish what is the common difference initially, leftmost, and the next 7 bits are the number of terms in the sequence for that particular difference, which will come up to less than equal to this. Then aside 2 bits for 4 different possible differences based on the previous one, and 6 bits aside for the number of terms for that difference again, and then 3 bits and 5 bits, and then 4 bits and 4 bits, and then 5 bits and 3 bits, and then 6 bits and 2 bits, and then 7 bits and 1 bits. Here what we have done, this is how I went about it initially. I said if we assume a value x as the number of terms, and if there are n parts in this, and I require x plus 1 into n equal to 64. If I take n equal to 8, then x plus 1 must be equal to 7. So basically 1 plus 7, 2 plus 6. That's how you can easily calculate it. Now, but the only thing is, this is the what occurs to first. But we know the fact that you can have, if you want to build up a larger number, you can start off with fewer number of terms of a larger number, or more number of terms of a smaller number, right? But here I have assumed what? The number of difference is large, but the number of terms also is more, which is a contradiction. If you can build up a larger number by taking more number of smaller terms, the number of terms for a larger number should be smaller, but the number of terms for a smaller difference should be larger. So with that in mind, if you can, we can reverse this. This is the original idea that came up with. Then we can reverse this. Now this so we can have, initially we can have 7 possible differences with only 2 terms each, 2 terms for each of those differences. Then you can have 6 possible differences with up to 4 terms, 2 bits or 4 terms for each of these. And then you can have 7 means 128 possible differences with 2 terms for each. 6 means 64 possible differences with 4 possible terms each. 5 means 32 possible differences with 8 possible terms in each for each difference. Then you can have 16 possible differences with 16 possible terms in each difference, followed by 8 possible differences, common differences, with 32 possible terms in each difference, followed by 2 or 4 possible differences with 64 possible terms in each difference, followed by 2 possible differences with 128 terms for each of those. So this will become variable. For each of these 8 differences, 128 differences, you will have only 2 terms. But then for those 2 terms means the difference will become divided by 2. That difference, again you divide it into 6 or 64 possible differences for each of those differences. Within that 32 possible differences. And if you have these 64 differences, here you will have 4 terms for those 64 differences. Here you will have like that. So now those common differences that we take in the AP, or we can take a geometric progression itself. That is, initially we try, let's say we have the value L dash. We don't know what the value of L dash is for a 64-bit coding. So if you assume some value initially 0, the smallest, if we assume, is 0 to R, then R to R square, then R square to R cube, like that we have this thing. So initially the difference will be dl minus 1 if we have to find out the initial difference. So what will happen here is the total value will come up to since there are 128 differences, it will come up to you will have R minus 0, comma, R square minus R, comma, R cube minus R square, and so on up to R power 127 minus R power 128. So it will be r power 128 minus r power 129. So these are the differences that you will get. There will be 128 of these. R power 128 minus R power 127. So there will be 128 of these differences. Now if we add up, we will just get some of these differences equal to R power 128 equal to some value 2 power L dash. Therefore R must initially be equal to 2 power L dash by 128. Now consider the largest possible difference, which is nothing but R power 128 minus R power 127. So that should give you R power 128 minus R power, now there 127, right? So this difference we know, but if we are taking AP as the terms for the sequence there will be two terms there which we will be taking in AP. So we have to divide it by 2. So this will become R power 128 minus R power 127 by 2. So this will be only for the largest value for DL minus 1. For other values it will be much smaller. So okay, now if we assume R is equal to 2 power L dash by 128, this will be nothing but 2 power L dash minus 2 power L dash into 127 by 128 by 2. These two, since there are two terms, the difference dl dash minus 1 will be equal to, for it, dl minus 1 will be equal to this. This will be equal to 2 power L dash minus 1 minus 2 power L dash minus 1 into 127 by 128. So this will be the initial difference. Now for the subsequent difference, we only try to find out for the largest one. Okay. Now here initially there are only 2 terms. The next one there will be, however, 4 terms, but there will be 64 values. So therefore we have dl minus 2 is what we need to determine. Must be equal to dl minus, okay, dl minus 2. Okay, now how many differences there will be in this one? Since there are fewer number of terms there, now the number of terms will be more, but the number of differences will be fewer. It will be equal to 64. So it will be dl minus 1 whole power 1 by 64. And right, you'll have r l minus 2 equal to dl minus 1 whole power 1 by 64. Okay, so now you'll have r dl minus 2 must be equal to rl minus 2 minus rl minus 2 power 63 by 64 whole. Now they'll have 4 terms there, so divided by 4. So for the AP series the common difference will be this. Now we know RL dl minus 2 is nothing but equal to 2 power L minus 1 L dash minus 1 minus 2 power L dash minus 1 into 127 by 128. So if we substitute this over here, we will get something like this. For dl minus 2. As you can see, the differences itself will be very, very small. So you can you should be able to code quite a large amount of information by this method. Right? So you will have 2 power L dash minus 1 minus 2 power L dash minus 1 times 127 by 128 minus 2 power L dash minus 1 minus 2 power L dash minus 1 times 127 by 128 times 63 by 64 whole divided by 4. So this will become 2 power L dash minus 3 minus 2 power L dash minus 3 times 127 by 128 minus this. Two power L dash minus 1 minus 2 power L dash minus 1 times 127 by 128 whole power 63 by 64 whole divided by 4. But here the number of terms you have, this will be that. Like that you will have to each time keep computing the difference in, you start off with fewer number of terms with a larger difference and try to code more number of terms with a smaller difference so that you are able to code information. This combines both AP series and GP series, but it will be a variable difference. You are assuming n number of common differences for you are assume variable number of common differences and fixed number of terms with those variable number of common differences. But those common differences themselves are in geometric progression. And you are starting off with initially more number of differences with fewer terms, only 2 terms, and finally proceeding to smaller fewer number of smaller differences and more number of terms. So this is one way of, you should be able to code quite a lot of information this way, because these differences will be very, very small. Even for a 64-bit you can pack quite a lot, you should be able to pack quite a lot of information, especially if you're trying to code only binarily.